Hi guys, welcome back to In Case of Econ Struggles. Welcome to another AP Micro Struggle. Today we're still talking about topic 4.5, but we're going to talk about the game theory part of 4.5. So here's what you need to know about this topic for the AP exam. First, you need to know what a game is. You need to know what a strategy is. Then we're going to talk about a Nash Equilibrium. Then we're going to talk about a dominant strategy in the case of Prisoner's Dilemma. So timestamps are below if you would like to jump around, but I think an example is going to be really helpful to learn all of these different topics that you see in front of you. So in order to better understand how game theory works, I'm going to start with a game. And I'm going to start with a game that many of you have probably played before. I'm going to start with hide and seek, but it's going to be a really simple version of hide and seek. What do I mean by a very simple version of hide and seek? I'm going to say there's a house, and there's a seeker, and there's a hider, but you can only choose what floor you're on. You can't choose to hide behind a couch or hide behind a door. Your only option is to go upstairs or downstairs. And as you might imagine, if both people end up on the same floor, then the seeker wins and the hider loses. And if they end up on different floors, then the seeker loses and the hider wins. And again, you're choosing which floor to go on simultaneously and without knowing what the other person is doing. So what is a game exactly? Well, a game has multiple players. So here we've got two players, Bill and Deborah. And we're going to have different actions. In this case, you have two different actions. You can go upstairs or downstairs. And the payoffs are going to depend on which action you choose. And just to make it easy, we'll say that you get +1 if you win and -1 if you lose. And that's going to be helpful later when we talk about how to set up this game more formally. And now let's talk about a strategy. A strategy is a complete plan of actions dependent on what the other person does. So for example, for Bill, Bill's strategy would be to say that if Deborah goes up, I want to go up because he's the seeker. And if Deborah goes down, then I go down. So that's his strategy. That's what he wants to do. Now he doesn't get to know Deborah's action, but if he did, those are the things that he would choose. That is his strategy because those are his actions given what Deborah is doing. And that's all a strategy is. It's just a really fancy word to say based on what the other person does, I want to either go upstairs or downstairs. Now, when we talk about game theory, we represent this game in a very specific way. It's called the matrix form or the normal form of a game. So if you see the word matrix form of a game or you see the word normal form of a game, this is all this means is this little matrix I've set up right here. And this just means the payoffs for different actions based on what each player does. So let's just walk through it slowly. So like I said before, Bill and Deborah can either go upstairs or downstairs. That's the only two options. They wind up on the same floor the seeker or Bill wins. They wind up on different floors, then Deborah or the hider wins. And like we said before, you get +1 if you win, -1 if you lose. So this is saying Bill goes upstairs and Deborah goes upstairs. That's what this box here represents. These are the payoffs if both people go upstairs. And we just said that if both people go upstairs, the seeker wins. So Bill gets 1 point and Deborah gets -1 point because she loses. And the way we write payoffs is we write this person's payoff first, then a comma, and then this person's payoff second. So if we talk about this box right here, what does this box represent? Well, this box represents that Bill went upstairs and Deborah went downstairs. That happens, then Deborah wins because they wound up on different floors. So Bill gets -1 because he loses, and Deborah gets 1 because she wins. Again, this is where Bill goes downstairs and Deborah goes upstairs. That's this box right here. So Bill went on a different floor than Deborah, so he loses and gets -1. Deborah was on a different floor than Bill, so she wins and she gets +1. The last box is going to be down, down, which means that Bill went down and Deborah went down, so Bill wins and gets +1. And Deborah loses, so gets -1. So these are all the possible outcomes of this game, because these are the 4 possibilities given both Bill and Deborah have 2 actions. And so now we're going to talk about something called best responses. And so what I'm going to do is I'm going to take a different color. This is what I like to do. So let's say, I don't know, orange. And I'm going to underline Bill's best response in orange. And I'm going to underline it in the payoff section, just so I can think about what Bill wants to do, given what Deborah is doing. So let's say that Deborah goes upstairs. So if Deborah goes upstairs, then notice that I'm thinking about this column right here. And if Deborah goes upstairs, then Bill is deciding whether or not to go up or down. If Bill goes down, he gets -1. If Bill goes up, he gets +1. 1 is better than -1, which makes sense intuitively, because if Deborah goes upstairs and Bill wants to win, which he does, then Bill also wants to go upstairs. And similarly for downstairs, if Deborah goes downstairs, of course Bill also wants to go downstairs. Now it's the opposite for Deborah. Let's just underline Deborah in green and go through that same exercise. So if Bill goes upstairs, then we're in this row right here. And if Bill is going upstairs, Deborah wants to go downstairs, so I'll go ahead and underline downstairs in purple. And if Bill goes down, of course, Deborah wants to go up. So this is just helpful because of the fact that now I know what Bill and Deborah's best responses to each other is, and now I know what their strategy is. Because again, the strategy is a contingent set of actions. So if Bill goes upstairs, Deborah wants to go downstairs. Bill goes downstairs, Deborah wants to go upstairs. And if Deborah goes up, Bill also wants to go up. And if Deborah goes down, Bill also wants to go down. So this is the basic idea of how you might see a game on an exam question. But now let's do this with a different game called the Prisoner's Dilemma. So with the Prisoner's Dilemma, what we're going to add is we're going to add this thing called Nash Equilibrium. Nash Equilibrium is what we think is going to happen in the game. That's what we predict will happen. Just like when we show a demand and supply curve, and we say this point here where they meet is going to be the equilibrium price and the equilibrium quantity, that's what we predict will happen in the market. We're going to predict what's going to happen in a game. We're going to use those best responses that we just did with hide and seek in order to help us find the Nash equilibrium. So here is the Prisoner's Dilemma. Prisoner's Dilemma involves two people, Bonnie and Clyde. They were caught for trying to rob a bank, and they are each in a separate room with a police officer. They can't talk to each other, and they are choosing whether or not to give information to the police. So they have two actions. They can either sit there silently and not tell the police officer anything, or they can snitch. They can basically tell the police officer that it was all the other person's fault and they were just sort of along for the ride. They can sort of try to pin the entire crime on their partner. And now what we're going to do for payoffs, we're going to assume that the police are assigning years of jail. And so we're going to have negative payoffs because less years of jail is better. So we want to have it closer to 0. So in this payoff structure, for example, negative 10 is the worst outcome. 0 or 0 years in jail is the best outcome. And this is 5 years in jail represented by -5. So let's go ahead. Each of them have two actions. So we have that similar payoff, that similar matrix that we did in the last example with hide and seek. And now let's do the same thing in terms of best responses. So once again, maybe I'll highlight Bonnie's best response in orange. So if Clyde snitches, Bonnie can be silent and receive 10 years in jail, or snitch and receive 5 years in jail. 5 years in jail is better than 10 years in jail. And if Clyde is silent, then Bonnie is choosing between 0 years in prison or 1 year in prison, which represents either snitching or remaining silent. And what she's going to do is she's going to snitch and get 0 years in prison. Notice that Bonnie never wants to be silent. She always wants to snitch no matter what Clyde is doing. We call that a dominant strategy. Bonnie has a dominant strategy to snitch because she always prefers to snitch rather than stay silent, which you can see because of the fact that we never underlined silent for Bonnie. And it's going to be the same for Clyde. So if I highlight Clyde's best responses maybe in purple, you can see that if Bonnie is silent, then what's going to happen, Clyde is choosing between 0 years in prison or 1 year in prison. She wants to choose 0 years, so she's going to snitch. And if Bonnie is snitching, then Clyde is choosing between 5 years in prison or 10 years in prison, so she's also going to snitch. And so you can see that Clyde also has a dominant strategy to snitch. Notice one main difference here compared to hide and seek is that this box has both numbers underlined. So that means that both Bonnie and Clyde have a best response to snitch, which means that this is going to be what we predict. This is going to be the Nash equilibrium for the Prisoner's Dilemma. Both people are going to snitch, even though if they colluded, they could get 1 year in prison each if they were both silent. But because both of them have a dominant strategy or an incentive to snitch, we're going to wind up in the case where both snitching. The reason why this is so useful is remember in the last video we talked about the cartel with Bill's Bakery, Deb's Donuts, and Colleen's Coffee, and we said that even if they were colluding, Bill decided to defect, but all of them have an incentive to defect, so we wind up in the situation where none of them are colluding. That's the same thing here. This is the cartel failure. This is the fact that if Bonnie and Clyde even said, oh yes, I won't say anything, they both have an incentive to actually snitch. So both of them are actually going to snitch. And we wind up right here in this 5 years in prison each situation. Now again, one thing to notice, these 5 years in prison, this is not the action that Bonnie and Clyde are taking. So if you're saying what is the Nash equilibrium to this game, the Nash equilibrium to this game is that Bonnie is going to snitch and Clyde is also going to snitch. When I talk about a Nash equilibrium, I'm talking about the actions. I'm not talking about the payoffs. So if you said that the Nash equilibrium was -5 and -5, that is incorrect because those are the payoffs associated with the Nash equilibrium. The actual Nash equilibrium is snitch, snitch. So this is what you need to know in terms of game theory. I've got a lot of other videos on game theory on my channel if you're interested in this sort of field. Comment below if you're not sure exactly which one to watch. But if this is helping you, or these videos in general are helping you and you haven't done so yet, please like and subscribe, and we'll see you next time for another case of econ struggles.